Lecture 9, Clustering, Part 4, the last part of this lecture. In this part, we are going to have the Netflix case about recommendations. So Netflix has a recommendation system which recommends customers to watch similar movies. So here we are talking about getting advice from data. So, and based on that, we can make the recommendations. So usually the recommendations are based on the customer's previous purchases and or previous purchases of the similar customers. Okay, this process could be hard without the help of computer because we need to process massive amounts of knowledge and data about customers, their previous purchases, and also previous purchases by the similar customers. I mean, customers with similar interests. Okay. Netflix is an online DVD rental, movie rental, and live streaming video service. And today we can say it has more than 200 million subscribers worldwide. So Netflix is available in more than 190 countries. And the Netflix revenue is about $25 billion in a year. Okay, so you can see how large is Netflix. So in Netflix, we can say the key aspect is being able to offer customers accurate movie recommendations based on their preferences and viewing history. So this is the core part of the Netflix. During the years 2006 to 2009, Netflix ran a contest and asking the public to provide algorithms to predict user ratings for movies. In that time, Netflix has an algorithm and it was called Cinematch. So, but Netflix wanted to improve the performance, improve the accuracy of the recommendations. So because of that, they ran this contest. In that time, they provided a training data set of 100 million ratings and a test data set of 3 million ratings. Okay, and the grand prize was 1 million USD for the team who could beat the Netflix algorithm, I mean the Cinematch, by more than 10% measured in RMSE. So the RMSE is the root mean square error. So that would be this RMSE is the root of mean squared error. So yi minus y, the predicted amount squared and over n. So this is the equation for RMSE, the root mean squared error. Okay. As the contest rules, they defined a progress prize for the case that the grand prize was not yet reached. So in that case, if any team could improve the best result so far by over 1% improvement, then they could get $50,000 per year up to time that another team beats the result by over 1%. Okay, and the teams must submit code and a description of the algorithm to be awarded any prizes. And if any team met the 10% improvement goal for grand prize, then the last call would be issued and 30 days would remain for all teams to submit their best algorithm. Okay. So these are the initial results. The contest went live on October 2nd, 2006, and just 6 days later, by October 8, a team submitted an algorithm that beat Cinematch. By October 15, there were 3 teams with algorithms beating Cinematch, and one of these solutions beat Cinematch by over 1%, so it qualified for a progress prize. Okay. By June 2007, over 20,000 teams had registered from over 150 countries, and the 2007 Progress Prize went to Team Belcar with an 8.43% improvement on Cinematch. And in the following year, several teams from across the world joined the contest. In 2008, the Progress Prize again went to Team Belcar, which contained researchers from the original Belcar and as well as the team of Big Chaos. And that time, their improvement was over 9%. So this was the last Progress Prize because another 1% improvement would reach the grand prize goal of 10%. Okay. And on June 26, 2009, the team Belcar's Pragmatic Chaos submitted a 10.05% improvement over Cinematch, the first time that they could beat the Cinematch by over 10% improvement. So in that time, the last call was announced, and there was 30 days for other teams to send their best algorithm to beat this best result so far. Okay. And during the last call period, 29 days after last call, the team Ensemble submitted a 10.09% improvement, and at the end, the time that Netflix stopped accepting submissions, the Belcar's Pragmatic Chaos improvement was 10.09%, and the Ensemble was 10.10%. Then Netflix would now test the algorithms on a private test set and announce the winners. Okay. And finally, on September 18th, 2009, a winning team was announced. Belcar's Pragmatic Chaos won the competition and the $1 million grand prize. So as you see here, Netflix paid over $1 million to just improve their performance on the recommendation system, and this shows how critical is the recommendation system for their business. So now let's see what data can be used to predict user ratings. So we know that on Netflix, some users rank the movies. So we have the ranking data for the movies that users rank them, and also we know some facts about the movies, like the actors, director, and genre classifications, and year release, and etc. Okay. There are 2 types of recommendations systems: collaborative filtering and content-based filtering. Collaborative filtering is working based on the attributes of the users. So in this system, the users are clustered, and based on the cluster of each user, the recommendation system will recommend movies to them. But in the content-based filtering, it's working based on the attributes of the movies or the items, and based on the movies watched by each user. Based on that, the Netflix or the recommendation system will recommend other movies to that user. Okay, and there are many systems that combine these 2 approaches to improve functionality. Okay. Let's have an example here for the collaborative filtering. Here, the recommendation system can recommend Carl to watch the Men in Black because it was watched by the AMI and ranked 5 by AMI, and since we see there are similarities in the interests of Amy and Carl, so these two users have similar interests, and based on that we can recommend Men in Black to Carl as well. Okay, so this technique is called collaborative filtering. So as you see here, we are somehow clustering the users. We are finding similar interests between the users, and based on that we recommend movies to users. So here we need to have a measure of similarity between the users to make rating predictions and recommendation, and this measure could be correlation. Okay, so yeah, we can obtain the correlation between the item vectors of user. I mean, each user will have a vector, right? A vector of items, and based on that we can obtain correlation, and based on the correlation we can cluster the users in similar groups. Okay. Here we have another example for the content-based filtering. So in the content-based filtering, it's working based on the movie's features. I mean the items features, not the users features. So here if we see that the Amy liked Men in Black, so we may see, okay, who's the director of this movie, and then we can recommend the other movies by the same director to Amy, right? Or the Men in Black is classified in the genres of action, adventure, sci-fi, and comedy, right? So based on these classification of the genres, we can recommend Jurassic Park, which has similar genre classifications. Okay, or we can see who is the star's actor, and based on that we can recommend other movies with the same star actor, right? So this is called actually the content based filtering. Here we are considering the features of the movies instead of the features of the users. Okay, and this is called the content based filtering. Okay, if we want to compare the collaborative filtering and content filtering, so here we can have the strength and weakness of these two approaches. For the collaborative filtering system, we can say, okay, it can accurately suggest complex items without understanding the nature of the items, right? And also it requires a lot of data about the user to make accurate recommendations, and if we have millions of items, you need lots of computing power. Okay, and for content filtering, it requires very little data to get started. Just some features of the movies, it's enough, but it can be limited in scope because it's not considering any features on the user side, and it's just on the items or the movie side, so it could be limited in scope. Okay, let's wrap up this lecture by reviewing the edge of recommendation systems. In today's digital age, businesses often have hundreds of thousands of items to offer their customers. So without having any system, I mean computer system, it would be impossible for people to recommend products from hundred of thousand items to customers. Okay, and excellent recommendation systems can make or break these businesses, right? And we see here that the clustering algorithms which are tailored to find similar customers or similar items, these algorithms form the backbone of many of these recommendation systems. So yeah, I mean, the most of recommendation systems in the real world are working based on the clustering algorithms. Okay, thank you.